INSA is one of the main engineering schools in France because it graduates more than 7% of all the engineers graduated in France. Since that date, I teach at the mechanical engineering department, focusing on modeling, simulation and control of mechanical power transmission systems, especially for aerospace. In parallel, I have a research activity at Institut Clément Ader, which merges in Midi-Pyrénées all the activity related to the mechanical domain. And within this laboratory, I develop an activity that is related to embedded actuation systems. And of course, in Toulouse, embedded actuation systems means aerospace. For me, the main issues for the aerospace industry is to face some challenges between incremental innovation and major steps that make some ruptures. So typically the problem is to have a view at the global product, which is to move persons from one side to another side, being greener, safer and cheaper. So today there is a big challenge in being able to design better and faster systems which involve more interactions between domains, mechanical engineering, electrical engineering, informatics and so on. So for our engineering challenges, AMSIP is interesting because because of the structuration of the model that has a high influence on the use of the model. So we are able to structure a model to think about interfaces, and something that we can very trust in is the reliability of the numerical solver. That is sometimes forgotten by the user. They only want results. If we change the solver, we change the results. For AMSIM, we can be very confident in the solver. For the flight control design, we have many things that have changed the modeling and simulation process due to the switch between technologies. At first, we were mechanically signaled and hydraulically powered. And finally, it was a situation that was quite well established since for hydraulically powered since the early 60s, and for fly-by-wire for electrically signaled since the early 80s for commercial aircraft. So this has generated a step in signaling. Then we had a step in powering by more electrical aircraft when we have to provide power to the actuators of the flight controls by means of electrical power. And this generates a very high change, which requires the engineer to have new approach. They can no more rely on the process they use for another technology, because we have some side effects that belong to a given technology. For these new technologies of actuators, especially considering powering, the interest of AMSIM, that was one of the first simulation tools to provide, is to be able to combine different physical domains, mechanic, electrics, electrotechnics, power electronics, hydraulics and so on, thermal. So now we have to address wider and wider domains, and as the actuators involve mechanics, electrotechnology, sometimes hydraulics with electrohydrostatic actuators, we have to be able to investigate a product which requires models in each domain. And finally, AMSIM is quite easy to use because we have very structured libraries that enable addressing all these domains with given interfaces, given parameterization, and that is well in phase with the demand.